Hey guys, I want to talk about linear functions for 2.4. The form of a linear function, it looks just like slope-intercept form because it really is. The form is f of x equals mx plus b. Now f of x, if you remember, that's the same as just saying y equals mx plus b, just saying, hey, by the way, this is a function. Now, if m is not equal to 0, the domain and range of the linear function is negative infinity to infinity. If m is equal to 0, then we're left actually with a horizontal line, and that won't be the case. Okay, so that's the one exception. So let's look at this. Graph f of x equals negative 3x plus 3. So if you like, which I like to do, you can replace f of x equals negative 3x plus 3 with y equals negative 3x plus 3. And if you remember, this m here we call the slope, which is the rise over run. Okay? So we could think of that as negative 3 over 1. That tells me how to get to the next spot. This spot right here, this 3, this is your b. That tells us that 0b is the y-intercept. So if I'm looking at this, I'll start at that point, 0, 3. Since this is a linear function, I know that this thing looks just like a line. So I need 2 points. So if my slope is negative 3 over 1, that means I'm going to go down 3 and over 1. So this will be the point 1 comma 0. And I'll just connect the dots. So we're right here. Okay, let's move to the next one. Standard form of a linear function. Ax plus by equals c. Maybe you've seen this before. It's especially useful in solving systems of equations, but also sometimes with graphing if you're going to graph using x and y intercepts. So notice what I have right here. Example, graph 2x plus 5y equals 10 using x and y intercepts. Now we did an example of this back in 2.1, but let me remind you. When your form of your function is like this, when it's implicit, it's usually easier to use x and y intercepts. Reason being is, if I'm looking for the x-intercept, recall that that means when y is equal to 0, when we're crossing this x-axis. So that would tell me that 2x plus 5 times 0 equals 10, 2x equals 10, or x equals 5. So I have the point 5, 0 right here. And if I'm looking at the y-intercept, that's when x is equal to 0. That means I'll have 2 times 0 plus 5y equals 10. 5y equals 10, so y is equal to 2. So that's here, 0, 2. I got 2 points, so I got a line. Now, suppose I have something in a similar form here, 4x minus 5y equals 0. And I'm going to try to do the same thing, use x and y intercepts. But here's the problem. When I let y be 0, that means 4x is equal to 0. So I got x equals 0. If x is equal to 0, then y is also equal to 0. So my x and my y-intercepts are actually the same. If I do the y-intercept, I'll get the same point. So I can't do it in this one. This is one of the rare cases. So in that case, I'll probably just pick a different value for x. Let's just let x be, I don't know, let's say 1. Okay, so if x is 1, then we're going to get 4 times 1. That's 4 minus 5y equals 0. That means 4 is 5y. Y is 4 over 5. So it looks like this thing is going up. So we go over 1, and y is 4/5. So we're about right here. In that case, I would just pick really any point. Okay, so that will start us off for 2.4.